Practice set for multiplication of real numbers. As always, don't forget to like and subscribe if you find this video helpful. Pause the video to work these problems on your own, and then come back to check your work. Okay, so this first set is intended to just review those signed number rules. And so the first problem is just straightforward 7 times 8, which we should remember from elementary school. 7 times 8 is 56. Now, the second one begins to introduce, okay, well, what if one of these numbers is negative? So if the 7 is negative and the 8 is positive, a negative times a positive would give you a negative. So the answer would be negative 56. And it also does not matter if it is the 8 that is negative. And you'll notice I am changing up the multiplication symbols there. So I'm going from the dot to the X, and we'll see on the next slide that I use the parentheses. Just it's important to be comfortable with all of the ways that we can write it. So if you have a positive times a negative, then that also would give you the negative 56. So positive times a negative, doesn't matter what order it is in, it would give you a negative. Now the last one is a negative times a negative, and that will give us a positive. So that comes back to positive 56. And this is really important to remember for later in algebra when we are trying to factor things and we might be looking for factors of positive 56. And so we want to remember that we could get the positive 56 from doing 7 times 8, but also from negative 7 times negative 8. So you have that idea of the same signs there. Now on this slide, we tried to introduce the variables a little bit. And so 5 is simply negative 3 times x. You would write that as negative 3x. Now I'm not intending to try to be tricky there, but I see so many of my own students when I ask them what is the operation between the negative 3 and the x, or whatever the coefficient is in the variable, and they will kind of get stymied and not know what I'm asking them. And so this is really to emphasize that when you see negative 3x or 4x or 5x or 1.5x or whatever it might be, that it is multiplication. That's the operation that happened there. Now for number 6, we see a negative x times a negative x. So a negative times a negative would give us a positive, and x times x would give us x squared. And so we're squaring the negative along with the x, but when we square the negative times the negative would give us the positive. And so that would be x squared. And then for number 7, we can go from left to right with our multiplication. So negative 2 times negative 3 is positive 6, and positive 6 times 4 is 24. And you can get there in any order. So you might have decided to do negative 3 times 4 would give you negative 12, and then negative 2 times negative 12 would give you positive 24, like however you wanted to do that. Coming back to evaluating, and remember, evaluate, that directional rule means to basically plug in the variable and say what it is equal to. So we have 2 times x squared minus 10, and we are going to plug in the negative 4. So that would be 2 times negative 4 squared minus 10. Now, quick little reminder here, negative 4 squared means negative 4 times negative 4. And a negative times a negative would give us a positive. And so this will be 2 times 16 minus 10. 2 times 16 is 32, and 32 minus 10 is 22. I'm going to pause for a moment and just re-emphasize top to bottom. Okay, so each step comes from the step before it in a logical way. This over here constitutes scratch work. Okay, and that is me making clear where the 16 comes from, that negative 4 squared does not give you negative 16. All right, and the last one here, evaluate for a is equal to negative 5, and this is bringing back some absolute value. It's a common thing for students to forget stuff that was maybe several lessons ago or that they don't see all the time. So it's good in a problem set to just see some symbols if we haven't looked at absolute value. Maybe it's been a while. Nice to see it. So we have negative 3 And then in the absolute value, we have -5 plus 4. And this right here is multiplication. Okay, so that goes to what is implied there, that is implied multiplication if you don't see an operator. So it's -3 times the absolute value of a plus 4. Absolute value is a grouping symbol. And so with the grouping symbol, it means that we will do that first. And so we've got -5, and we're going to add 4, 1, 2, 3, 4, and that is going to put us at -1. So we have -3 times the absolute value of -1. Absolute value of -1 requires that we remember what absolute value is. And so absolute value is the distance from 0 on the number line, and -1 is a distance of 1 unit from 0. So the absolute value of -1 is 1, and -3 times 1 is -3. Again, show that work from top to bottom. And if you have scratch work, make sure your scratch work is off to the side. This question is more of a reflection question, and this is a really common thing that can get tripped up later on in algebra when you study a family of functions called quadratics. And so I think it's worth right now at the beginning, when we're talking about variables and negatives and operations, order of operations, all that kind of thing, to think about this. What is the difference between -x squared and -x squared? Now, when we say these out loud, they often will read identically. Like we'll read the words -x squared. Now, sometimes you will hear with this second one, -x all squared. So you'll hear the word all, A-L-L, in there, and that word all is meant to signify the presence of the parentheses. So -x all squared, meaning you are squaring the negative along with the x. And that is one way you might hear it differentiated verbally from the one on the left there. And for some reason, I think I said left when I meant right, but I'm sorry if I did that. Okay, so the first one, -x squared, the negative here only goes with the x, and that goes back to, the squared there only goes with the x. And that goes back to an earlier video where we talk about what the exponent goes with. It only goes with the thing immediately to its left. And so the squared only goes with the x. So the negative in this case is actually not being squared. X squared is x times x, and so the negative would float out in front like that. And so if x were, say, 3, okay, we'll just make this up. Okay, say x equals 3, then this would be -3 times 3, or -9. This one, however, the negative is in the parentheses, meaning the negative is getting grouped with the x, and the exponent then is applying to both the negative and the x. So this one would be -x times -x. So once again, let's say x is equal to 3. In this case, you would have -3 times -3, or +9. And I think you can probably see where this could lead into problems later on if you were to encounter x squareds in things, and maybe the number you're plugging in is negative or the number you're plugging in is positive, and you want to make sure that you're either squaring or not squaring the negative as is necessary for that particular problem. Now, for now, I think it's just plenty to just look at those and see how they are different and see how they relate to the concepts we're studying right now. As always, if you found this video helpful in any way, please like, subscribe to the channel, and comment on it. Let me know what you'd like to see in the future. See you in the next one.